All right, today we're going to talk about the rib relay, relay in a box. That's what it stands for. A lot of you may walk right past this on the part shelf at an HVAC supply house, not even realizing that this could be on your truck. It's used for a lot of building automation because there's 3 different coil voltages that make this relay special. There's also an indicator light right here that tells you when there's coil voltage. That coil voltage can be volts direct current, volts alternating current, whether it's 120 low voltage or 24 volts low voltage. Yes, I said 120 low voltage. So wherever your application is, this relay does come in handy. But can you use this in a residential application for a blower motor if you didn't have anything else? Absolutely, yes you can. And so if you stay tuned to this video, we're going to show you how to do that step by step. All right, the CANTEX box, we're going to talk about the rib relay. A lot of people don't understand what the rib relay is for. Typically, if you do industrial work or any type of building automation, you're going to run into a lot of 120 applications, DC applications, and VAC applications on the low voltage 24 volt side. And so this relay is typically stocked because anything that needs to happen, there's just more applications that you can use that particular relay for. And so you can use this relay in a residential application. We're going to talk about how to do that today. At the CANTEX box, we have our light bulb, we have our 24 volts primary, we have L1 and L2 present. L1 and L2 is your line voltage. It's 2 legs of power, so we have 240 volts of electricity. This is danger close, so we can practice using this relay to try to get this load to work. So we don't have to learn in the field as much. At the end of this, we're going to go to a fan motor where we're going to show you how to use this as a blower relay. And then we're going to take it to the smart board and show you how to wire it up step by step. To get started, we're going to go ahead and demonstrate the power that we have. I'm going to do this with the light on and with the light off, just so viewers have the opportunity to see it both ways. With the light off, we have, let me turn the breaker on here, excuse me. We have 27 volts. Okay, then between L1 and L2, we have 240 volts. I'm going to try that again with the light on. We have 27 volts. And between L1 and L2, we have 240 volts. And our goal is to get this line voltage up here between T1 and T2 so our load can run. This light bulb can represent a fan motor, compressor, anything that we want that's in the 240 volt world. Wiring it up without the relay, we're just simply going to bring line voltage up to each terminal. We have L2 to T2. And then we're going to bring L1 to T1. And I'm going to go ahead and touch it. And the moment I do, you'll hear the contactor inside the box click. And then the load will energize. Okay, so I'm just going to go ahead and leave that on there. Now what our next goal is to wire this up to the relay. And there's a couple of terminals that are for coil. And there's a couple terminals that are for the contacts. There's a label on the relay where it shows you, that you can use common on the 24 volt side, common on the DC side. When I say 24 volts, I'm referring to volts alternating current. DC volts between 10 and 30, DC volts direct current, or 120 volts alternating current. I don't have a neutral up here, so I can't demonstrate the 120, but I can show you the volts alternating current between 10 and 30 volts because we have 27 volts between R and C. So we're going to use this as our coil voltage, and then we'll demonstrate the normally closed and the normally open. So before I put 24 volts on it, normally closed would be blue and common would be yellow. So here's the yellow wire. And so to do this, that means I would take any leg of power, doesn't matter if it was L1 or L2, that line voltage, and I'm going to go ahead and connect that to yellow because yellow is common. All right. Coming out of that, if I wanted to pick the normally closed, it says here the blue wire, which is here, is the normally closed. I'm just going to touch this to T1. You should see the load come on. All right, so now I'm going to go ahead and connect power there. And we're going to come back and connect that to T1. And so if I wanted to connect this to my normally closed, the load would always be energized, and then when I apply coil voltage, the load will drop out. So we're going to go ahead and apply coil voltage. I'm going to use green for common, and it says here, common here would be white/yellow. Well, that's white/yellow, so I'm going to go ahead and connect to here. And then I'm going to take another wire. We'll just use this red one here. And we'll use this as our 24 volts alternating current. And that's going to go to white/blue. Okay, so this is our white/blue. And the moment I connect this, we'll have 24 volts. You'll notice that a red light will appear on this rib relay. That's telling us that we have coil voltage. And obviously, once I apply that voltage, our normally closed terminal will open up and the load will shut off. So let's go ahead and do that. And so you see we have the light that came on the rib relay. And I'm going to hold these because all these are just kind of floating here and I don't want anything to touch anything. So I'm going to be careful with that. And the light came on. So I have one spare wire because I'm not using that, and that's going to be my orange. My orange would be my normally open. Okay, I'm going to go ahead and remove coil voltage. As you notice, the red light went off. And I'm going to go ahead and remove my common, since all these wires are just floating here, so nothing touches anything that I don't want it to touch. And let's see here. We want orange to go to T1. So we're going to go ahead and release the wire on blue, okay, which is the output for normally closed, and we're going to apply this to orange for normally open. All right. I'm going to put 24 volts back on the relay. This is how you would traditionally wire this for your blower relay. So we're going to take our common. We're going to go back to white/yellow, which is common. Here's white/yellow. We're going to go ahead and connect common there. Okay, I have two more wires. I can only pick one. That white/blue will be my 24 volt side. So we're going to go ahead and connect to that. You'll notice the red light will come on because, again, we're energizing the coil, but except this time our load will activate because right now it's in the normally open and we already have that part wired up. So we're going to go to white/blue, give it 24 volts, and now you see the load came on. It was wired to normally open, and again our red light came on because it was for coil. Again, I don't have a neutral here, so I can't really show you how to change my coil voltage and get this to run here. When I get to the fan motor, I have a neutral on my extension cord. I'll use that just because. And that's pretty much everything this does. Now, as you can see here, I have a spare wire. I'm going to go ahead and cap that off. My other spare wire, which was white/black, go ahead and show you that. I actually had a wire nut on that one the entire time. White/black will be if I had 120 volts and I wanted to put it on this and I was using my common as a neutral, so I had a path for coil voltage, I would use that. So this is my one spare contact that I'm not using, my normally closed contact, so I'm capping that off. And then I'm going to cap off my 120 side for my coil that I'm not using. So as you see here, I've got 6 wires: blue, orange, yellow, white and black, blue and black, and I have yellow and white. So those are my 6 wires. I'm only going to use 4 of those wires in any of these applications here, So the other two, they have to be capped off. I'm going to go ahead and wrap up at the CANTEX box, take it over to the fan motor, and show you how to use more of these wires over there where I have a neutral present. Stay tuned. Okay, now we're over at the fan motor. The fan motor has a green light bulb this time. We have a rib relay. I'm going to go ahead and show you that this is always in a red box. This is how they brand it, RIB. Stands for rib relay, relay in a box. And at the end of it, you know, you can use this for a blower motor. You can use this for a light bulb, pretty much anything on the building automation side. And it's always on the shelf, typically at your HVAC supply houses. May be there for a lot of commercial applications, but don't walk right past it because it's not that expensive of an item. One of the things that I like about it is its versatility and its diversity that you can use on a job site, meaning you can use it for different coil voltages. If I had 12 volts DC, if I had 9 volts DC, if I had, excuse me, not 9 volts DC, I backed that up, 12 volts DC. If I had 24 volts alternating current, if I had 120 volts alternating current, and I wanted to, if that was my only voltage that I can use for coil, I can do that. Now, as far as the contact side, it doesn't matter what you use it on the contact side. The only thing you have to keep in consideration is the amount of ampacity that you can pull across the point so you don't create any problems with too much power. This one is good for about 10 amps, and then they do go up to 20 amps that I've seen. So the other thing that I like about it is this little red light here. That red light is an indicator that there is coil voltage. So if you had to put a bunch of these in there, as you can see, there's not your traditional terminals like you see on a relay. It's just a bunch of wires coming out of it. And all those wires, some of them I have them capped off because there's 6 of them and I'm only going to use about 4 in this application, maybe 5. However, if I wanted to see if I had coil voltage, I can just look for that one red light right here, which would be an indicator, and that's pretty neat. So we're going to get right on into it. We got a power supply here with R and C, 24 volts. We have line voltage over here with the live 240 volts of power. The meter here will show you if you see the light bulb talking about the path. We have the high voltage wire going to it. It's not hooked to anything coming out of it. This other black wire has got a gray wire nut on it coming to a white wire. That will be plugged into the neutral on an extension cord, so I can provide a path if I want to use 120. The capacitor is pre-wired, and as far as the motor goes, the PSC motor has 3 speeds. We have red for low, we have black for high speed, I have blue, which I have wired nutted off here, that is for medium speed. And the other one is the other leg of power. And as long as we put 240 volts of power, then that motor will run. So let's go ahead and go to the meter, demonstrate our power for transparency. We're going to come over here and we're going to turn the backlight on. And you'll see right now we're reading 0 volts. When I come over here to line voltage, you'll read 239, we'll call it 240 volts. And when I come over here to R&C, you should see that we have 27 volts. With that, I have an extension cord here, a little green extension cord. I'm going to show you where I have 120. If I put one lead inside the extension cord for neutral and go to any one of these, you'll see that I have 120 per leg. And I'll need that if I want that light to come on. And so we're going to go ahead and show you now how to wire this up to the light by itself. And now that I have neutral, I can show you over here using 120 for coil, not just the 24 volts for coil. I'm going to actually show you both ways. So looking at this, we have 3 wires. And this is actually in the top left corner of your screen. We have this diagram here up so you can actually see the terminals that I'm talking about. We have white and yellow, we have white and blue, and we have white and black. So all the wires that have two colors on it, white with another color that's striped, that's my coil side, all right? And then I have blue, a solid blue. I have a solid yellow and a solid orange. That's going to be my contact side. So one of those, the yellow, will be my common coming in, and then which is my input, and then my output will be blue, which is normally closed, or orange right here, which is normally open. So a lot of different ways we have to wire this up. Getting right on into it, I'm going to go ahead and first show you that if I were to take one leg of power, we'll just come to line, and then we'll come over to, let's say we want to do yellow for common. I'm going to go ahead and connect that. All right. Then I'm going to show you right now that if I were to connect the blue, which is normally closed, if I were to connect that to my light bulb and then make sure that I have neutral to my light hooked to my extension cord, that light will come on because that's normally closed. So let's go ahead and we're going to go ahead and put neutral on it. And so our light came on. We're going to go ahead and leave neutral there. And so that's normally closed. That's just one leg of power running through the normally closed portion of the relay. Obviously the red light's not on here, so there's no coil voltage. I'm going to go ahead and apply coil voltage now between common, and we're going to find common on the coil side, which are all my striped wires. So I'm looking for the white and yellow stripe. Here's white and yellow. I'm going to go ahead and connect common to that. These are all floating, so I have to be careful not to touch anything, cross paths. And then the we're wanting to use 10 to 30 VAC/DC because we're dealing with 24 volt alternating current power supply. That'll be white/blue. So I'm looking for white/blue to energize the relay, which will open the normally closed side of the contacts. As you see there, the red light come on, indicating that I have 24 volts on our relay. And because I was wired to the normally closed side, obviously that opened the moment that we applied 24 volts there. So I'm going to go ahead and unwire that. You see we lose the 24 volts. The red light goes out. Normally closed is now engaged, and the green light is on. There we go. So we're pretty much going to do the same thing with the motor. Of course, the motor is going to need a second leg of power if we do it there. Let's go ahead and unhook the light bulb. We're going to go ahead and cap blue off. All right, remember the solid colors, these are our contact side. We're going to wire our motor obviously to the orange, which is normally open. So we're going to go ahead and take orange, we're going to wire it up. To common. Let me go ahead and get some of these other wires out of here just so it's not too confusing here. Just like in your equipment, there's wires running all over the place, so you have to be very careful to inspect everything to make sure that you don't cross paths. So we have we have one solid color wired up, which is yellow. That's line voltage coming in as an input, and then that's the only thing that's wired up right now. So we want to go ahead and take orange, which is normally open, and we want to wire that to one side of our fan motor. We're going to go ahead and pick black, which is high speed. I'm just going to push this inside of it. That should make a good enough connection there. Okay, and that's for the fan motor. We're going to go ahead and wire up the other side of the fan motor. I'm going to go ahead and use red for our other line voltage. And that's going to go to the white wire on the motor. Okay. And now the moment I give my coil, my rib relay, 24 volts, the contacts will close. You'll obviously see a red light and the motor will come on and run. So we're going to go ahead and take common, and we're going to wire that to common on the coil side, which is a two-tone color. It's a solid with a stripe on it. So we have white/yellow. Here is white/yellow. So there's my common. Very easy. I love wiring this thing up. You can't really mess up. They made it so very clear here. And then I have white/blue, which is this one here hanging down. That'll be where I apply my 24 volts to that. So I'm going to go ahead and connect 24 volts there. You'll see the light come on and the motor will run. There we go. And this is how you would traditionally wire this up as a blower relay. And now any spare terminals that I'm not using, for example, I'm not using, let's see here. We have 1, 2, 3, 4. So yeah, so all my spare ones that I'm not using, like this white/black, that's capped off, in my blue, which is normally closed contact, that's capped off. So out of the 6 wires coming out of this, I'm using 4. The other 2 are capped off. Make sure of that, because they'll be floating in your cabinet. You can't just use electrical tape. You need to cap them off. And so if I wanted to wire one of these normally closed ones to my light, I have blue here. I can simply take this, come out of that, go ahead and, excuse me, there we go. That should stick. And now if I lose 24 volts, my light will come on. This is wired up 2 loads to my relay using the normally closed and the normally open, orange and blue. And if I were to remove 24 volts, then the top load will come on and the bottom load, the motor, will shut off. So we want to go to the blue wire, sorry, the white/blue wire right here. And we're going to go ahead and disconnect that. And this removes 24 volts. You see the rib relay now has the light off, the motor is off, and the green light bulb is on. We'll simply connect coil voltage again. The motor comes back on, the coil voltage indicator is there, and my normally closed load turns off. So this is an example of how to wire 2 loads to this relay, which is a single pole, all right, double throw. There we go. So I'm going to go ahead and take it now to the smart board. We're going to wire this up step by step. Stay tuned. All right, so that was some pretty interesting stuff that we talked about. We showed you how to do this on the CANTEX box. We showed you how to do this with a fan motor. Now we're going to take it to the smart board behind me, and we're going to show you how to wire this up. This rib relay is a really good relay. It's a rib relay that is very common. There is another one that has a higher ampacity. This one's pretty common for residential application. The one for 10 amps and below. The other one is 20 amps and below. If you buy the 20 amp and below one, you can use it for anything down to 1 amp. If you buy the 10 amp and below one, you can't use it for anything above 10 amps because those contacts aren't rated to handle that, and you might melt, cause a problem. That's not good. Behind me, I have the timeline. This timeline is over a 30-year period. It does go further back to 1990. What we're talking about is what happened to standard air handler technology on our blower components. How did we go from 3 components all the way down to 1? And why did we do that? And more importantly, if I can't put this component back in there and I have these other components on my truck, how are we going to put those in? It's called a conversion for a reason, because you're taking everything that is built into the backside of this motor, the module portion, and you're now having to add a capacitor and add a relay so you can toggle the motor on and off. That's all you're doing here. But back on this end of the timeline, the PSC motor, permanent split capacitor, you can see that we have the capacitor there, and we have the rib relay of choice on today's topic. And as we progress down this timeline, we started getting into control boards so we can manage time, that on delay or that off delay, so we can get more efficiency out of our evaporator coils. Those evaporator coils, they get cold, they get warm. They get warm when they're in heat mode, they get cold when they're in cool mode. And so if we can delay just for a little bit on that on time, we can get more comfort out of our motors when they first start to move air across those coils, getting more heat or more cooling capacity out of it with extra dehumidification. That same thinking was there on that off cycle. So if the coil's still warm in heat mode, or if it's still cold in cool mode, let's go ahead and get a little bit more runtime out of those fan motors on an off delay once the thermostat said we're satisfied. And so that was just an efficiency, a comfort thing. That's all they were trying to do. As we progressed down the timeline, they said you don't need these capacitors anymore. These ECMs, these electronically communicating motors, they now have capacitors built into it. We call it the module, and inside of that, you know, everything is there. All you needed was a relay, which if you're in this situation and you're not getting the relay portion to come on, but the motor tested out fine with the module, then you can simply put even a rib relay right there, and you can wire that motor up for it to come on. In the event that that wasn't the case, you would have to change your motor out, which you can go back down this way and add a capacitor and a PSC motor, still using your control board. A lot of these videos, it's a lot of different varieties of relays and control boards that we're going to introduce, so we can go over in as much depth as possible. We try to introduce extra loads because there are other terminals there, and we don't want you to look at those relays and say, hey, you know what, I don't need that because those extra terminals we're not using. I don't need this relay because I don't have anything that's direct current. I don't have anything that's 120 coil. I don't have anything that I need for normally closed. Why can't you just use this relay for what you need it for? Cap off the other wires, use your normally open contact side, and put 24 volts on it. It's perfectly fine. The nice thing about this relay too is, if you can see here, I can take a 3/4 inch knockout or just create one with my unibit. I can slide this in there, put a lock washer on there, screw it on, and on the outside of my cabinet, that can be mounted there, and I know if, you know, I'm energizing my load by just coil voltage and that light's on. So pretty neat stuff there. Once we get down to the last component here, now Standard Motor Technology has given us ECM motors that have the relays, control boards, or capacitors, and or everything's integrated right into the backside of that motor. So it's a module that's bad or a motor that's bad, and we'll get into that on how to test those you know, modules and how to test those motor windings. Getting right into it, we're going to go ahead and wire this up. I've added a light bulb. Why not? I'm trying to keep these entertaining. I want to make sure that everybody can get something out of these. If you think that you're good to go, I'm hoping that there's something I can say that may resonate some additional knowledge and allow you to feel at least more confident about this relay and how to help that customer out. What I've done here is I've actually got the rib relay here, plus I've also got the diagram so we can wire this up, because it'd be kind of hard to sit here and show you how to wire up to each one of these wires like we've been doing. A lot of this stuff is in a dark, cramped environment, and it's hard to already see this as it is. So at the end of it all, you know, you need to have confidence in what these terminals do and what they're for. We have L1, L2 up here. We have a transformer. We have a low voltage terminal block, a Honeywell thermostat, one run capacitor or light bulb that's already been pre-wired to neutral. Picture of a rib relay, picture of the diagram, and we have a picture of our motor windings on what's going on here. This is just one speed. I don't have 3 speeds on here. I'm not trying to make this super complicated. I don't have a W2 or a heat strip in here. That's not what we're trying to do. The purpose of this video is to make sure that you understand how to wire these contacts and these coils based on what I have up here for L1, L2 and neutral with these loads. All of this stuff is still going to be relevant. However, like I say in a lot of these videos, we'd have to sit here for 90,000 hours to continue to talk about everything, which will eventually hit that. But as of right now, we're just trying to come here from how do we take L2 and L1, wire this motor up with this relay, but also because we're using coil voltage, we need 24 volts. And yes, thermostat has to toggle that. So we've introduced some of these other components here, not for the video's purpose, but for the purpose of it is within your scope, and we want to try to make this as simple as possible. We have L1, L2, and we have 24 volts. As I say, let's go ahead and practice safety. How we do that is we're going to do one leg of power at a time. Once we're done with that, we're going to inspect that leg of power. If everything looks good, we're going to go to our next leg of power. We're going to go ahead and wire that up. Once that leg of power has been inspected and we're confident with that, then we're going to go to our secondary control voltage, and we're going to go ahead and wire that up. At the end of it all, we want to make sure that we're not taking everything that's red or everything that's black and just start hooking things up high voltage and low voltage at the same time. Some people won't wind up wiring up one component at a time. I don't think that's a safe thing to do, because you can easily, start wiring up one component and then you can forget that, hey, that red wire was high voltage and that other red wire was low voltage, and you don't want to cross those paths. Those paths need to stay separated for your safety and the well-being of the equipment. Getting right into it, we're going to go with L2 first, and make sure I get my colors right. Yeah, we're good. We're going to go ahead and wire up one side of the transformer. All right, there's L2, and we're going to come down. And if you look here, I've got one side is my coil voltage, one side is my contact. I have an input and two outputs. Well, this middle here, the yellow common, that is a input. And as power comes in, it's going to come out on the normally closed, or it's going to come out on the normally open. Over here on my coil side, I can either feed it 120 volts with a neutral, or I can feed it 10 to 30 volts direct current, or 10 through 30 volts alternating current. Now, in this application, I do have 120 volts between any one of these two legs and neutral. All right, so we're going to take advantage of that just to show you what that will look like. But I don't have any direct current here. I would have to put another transformer in here, step down voltage to get that DC, and again, we'll just be here for 90,000 hours, and we're trying to get through. How do we just take this simply and wire that up as a blower relay? So I'm only going to wire 2 out of these 3 coil voltages, and I'm going to wire both of the output contact voltages. So we're going to come down first, and we're going to wire this up traditionally. So L2 next will come over, and I'm going to come over to common, which is my yellow wire. All right, and I'm going to input one leg of power. At that point in time, at this point in time, I now have power right here. I don't have power here yet, but I have power here already. And so we're not done yet because I need to come out of my output for normally open, and I'm going to run that over here to common. And there we go. And so now I'm going to step back. I'm going to go ahead and inspect it. L2 to the transformer. Check. L2 to common on the relay. Check. L2 will come out, come over to my motor. Check. Now if you notice, R and S stand for run and start, and they're both the same color, red, as well as L1. It doesn't have to be that. It's just to show you that these will be on this same leg of power. So I, again, don't cross paths. And what I mean by cross path, I'm talking about L1 to L2. That would not be good. So we're trying not to cross paths at all. So again, we're going to inspect. L2 check, L2 check, out of here, L2 check. Nowhere else does L2 have to be present. Now I can safely work on the other leg of power. So we're going to come over here. We're going to come out of L1. We're going to land power on the the line side of the transformer. Okay, it says line here, it says load here. Well, L1 and L2, that is line. So now our transformer on the high voltage side is complete. Transformer's not complete, but on the high voltage side, it is complete. We're going to come down here and we're going to go ahead and run L1 over to our run winding. Okay, we're going to go ahead and label that L1. And the next thing we need to do to complete this circuit is we need to energize the run capacitor. So it needs a leg of power on it, the same leg of power that the run winding has. And then out of this capacitor, we need to come out and we need to energize the start winding. So this capacitor is providing a third leg of power. However, we don't call it three-phase. It's single phase. There's only two legs of power here. But what you need to understand is on two of these windings, it will always be the same leg. The other winding will be the other leg. So we have everything done on the high voltage side, and we are ready to wire up the low voltage. We're going to come out and put 24 volts on our terminal block. There's no inline fuse here. Again, it's not a 90,000 hour video. We're going to come out of this terminal block and we're going to energize the float switch. I'm sorry, not the float switch. You should go through your float switch, then go to your thermostat. But we're going to go to our thermostat, and then out of our thermostat, we're going to come back with common if there's no DC voltage for a display like batteries provide. And we're going to create a path back to the transformer. There we go. And now we have 24 volts. There's our loop. We have a display. And now whatever mode that this thermostat's programmed for heating, cooling, G-call, whatever, it's going to toggle 24 volts onto those terminals, and it's going to energize this terminal block, which then we can take power from here and run it to my coil voltage. We're going to come over and pick a couple of different colors. We're going to come over and say that the thermostat provides 24 volts on O for cooling, and it provides 24 volts on Y for heating by itself, or to get the condenser to come on, we'll say. And then G is what we're looking for. G is energized by the thermostat to get the fan to come on for any one of these other modes. But mainly if the thermostat needs to call for the fan to come on by itself, just for fan on, it can now do that. How do I want to run this so it's clean? I'm going to come down just like inside your air handler. You have wires all over the place. That's why I try to color code this the best as possible to try to confuse you the least amount. I'm going to take my common as a output out of my coil. I'm going to run it back up this way and join that with my common on my transformer. And at this point in time, I now have coil voltage, so L2 can come over and be present right here. So this will close, this will open, and L2 will come on and will energize the motor. So now I'm going to take it a step back. I'm going to go ahead and delete a couple of those steps and see how many more I can delete. Good, so now there's no 24 volts here at all. So if we looked at everything right now, there's no 24 volts there. So I don't have L2 here at all because this is open. So where would I read power at? So what we're getting at is right here. We're saying that if I have L1 here and L1 here, and I follow the path of electricity, then that path of electricity puts L1 right here. And if you follow the path all the way back to here, that means L1 is also present right here. So if I wanted to check my relay, say I was getting a red light here on the relay telling me that, hey, you have coil voltage, say I had 24 volts here, and I still had L1 here and L2 here, motor wasn't running, I would actually read that difference of 240 volts, two different legs in different directions. I would read that on my meter. That's how I would know that I have a bad relay. Now, sometimes this light here, this little diode, it can go bad. That doesn't mean the relay is bad. You can change it if you like. But if I didn't have my light on and I measured no voltage here, and I had 240 here, then there's something going on with control voltage. So let's go ahead and put 24 volts back. We're going to say that the G call comes in, energizes the coil, common, back out, gives me a path back to my transformer, and at that point in time, L1 is no longer here, L1 is here, the path of electricity is no longer here, simply because now we have L2 present at this present time, and we have L2 present. So what if I wanted to use, say I wanted to wire my light bulb too. I can sit here and say, all right, let me just go ahead and use purple. As an output here, I can take this and I can run it over and energize my light bulb and have my light bulb come on and run, just like I did when I had the fan motor here and I was showing you with the light bulb running on the normally closed terminal and the fan motor running on the normally open terminal. So here I've got orange wired to my motor. Here I've got blue, solid blue, wired to this purple here, which is energizing my light bulb. And so if I lose 24 volts here, then L2 will be now present here, and excuse me, L1 will be, L1 will be present here. When I get 24 volts there, when I have my 24 volts input here, then all that changes and I don't have L2 present here anymore. Where I have L2 present is now here. And so L2 will be here, the motor will run. But what will I have here? Well, the moment this opens and this closes, right, then what will happen here is neutral's a path all the way through the filament in the bulb, all the way back to here. So theoretically, I'm going to have neutral here at this present time. Until there's L2 present, then neutral will be back over here. But when L2 is not present here, neutral's path will be here. So I would measure 120 between here and 120 between here. Between here and here, I would read 0. Between here and here, I would obviously read 24 volts. Let's see if we can do this another way. I'm going to go ahead and erase all this. Erase it because it's easy and we can always do it again, right? All right, so now it's a clean board. We're going to go ahead and work on 2 loads real quick. We're going to say we need 1 leg here, 1 leg here. That puts out 24 volts. Here comes to here. Path back to the low voltage terminal block and then back to common, creates the loop. And now we have a display on the thermostat. And if I wanted to just come down here and say, let's put 1 leg of power right here on the 120 Then I'm going to go ahead and take, let's use neutral here, or purple for neutral. I'm going to come out of here and say purple, which is going to be neutral, would have to be here, and I'm going to draw my arrow going back towards neutral, because this would be an input, this would be an output, and right here, this would be an input. All right, and so now I can take that 120 and I can say, hey, you know what? I want 120 to energize my motor constantly. I don't know what you would do that for, but we're going to go ahead and have fun with this thing. We would say, all right, well, I also have to have a leg of power here. Let me go ahead and start labeling these. L2, L2, L2. We would come out of here. L2. Let's go ahead and get some red in there. L1. L1. Out of here. L1. Start windings now energized. Run windings now energized. And the moment I had 120, and we're going to call this purple wire neutral. All right, this would provide coil voltage, which would close this, open this, and then L2 would be present down here, right? In this application, and our motor would run. Doesn't make a whole lot of sense because there's nothing to drop out neutral. There's nothing to drop out L2. So the way we have this wired up, and definitely we would have coil voltage, and then definitely the motor would run. So we wouldn't do it that way. And so, but I'm just trying to demonstrate, could I get this to come on if I landed L2 here? Sure, but there's nothing here to break L2. So we would not do that. So in your application, how we would wire this for you, simply, we're going to go ahead and, like I said earlier, we're going to wire everything that needs to have L2 output. Inspect it. L2, 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 L2. We're done with L2. We're going to come over here. We're going to wire up L1. L1. We're going to come over here. Give our capacitor L1, come out of here, over to our start winding. That's obviously L1 also. Now we have our L1 and L2 100% completely done. We're going to come over here. We're going to wire our low voltage terminal block. We're going to come over to the thermostat, provide it with 24 volts. We're going to give it a path back to the transformer. And as long as we have that, then we'll have everything else. And then we'll have our Y, our O, and the one we're going to wire up to our coil is the G. That's the only one we need to be considering. So here's the G call. We want G to always run in the event that we need the fan to come on, whether it's for cool, heat, or just blower by itself. And then obviously common will be an output. We're going to come back through and wire that back to the transformer. And the reason why I wanted to leave off on this note, because I don't want to leave you any confused. There's no need to rewind or anything like that. We're not wiring a light bulb in this application. We're just going to leave that alone. This is how you would wire this and your normal practical application to use this relay as a blower relay. And like I said earlier, once you apply 24 volts here, this red light will come on. So if you wanted to mount this on the outside of the cabinet with that 3/4 knockout, you can. So I hope this video gives you a little bit more confidence when you see this on the shelf. Please pick it up, put it on your truck. It'll get you out of a jam. If you do a lot of commercial and residential, or if you do industrial, commercial, and residential, or if you just do industrial and commercial, it's still a good relay to carry. Like our channel by subscribing. Nothing's better than that. That way, when we release more videos, you're staying tuned to them. Give us a thumbs up. We need that to help support the algorithm. Share this with others. It's our job to share knowledge. Leave a comment in the box. We appreciate all of our viewers. Thanks for watching this. Stay tuned.